Welcome back to my channel, everyone. Sri Tips here. What we're going to do is refine a little bit of gold that we've accumulated over the past few days. This is our 14K material. We've got 27.7. And then zero the scale. Here's our 10K material. That's 31.6 grams. And then here we have some 18K material. That's 21 grams of 18K. I've calculated the amount of silver that I need for each of these amounts of karat gold. 94.9 grams total. The estimated yield for this group, this amount of karat gold in here, is going to be 44.9 grams. I need 94.9 grams of sterling. And here I have a sterling silver bracelet, and it weighs 95.1. So that'll be close enough for us. We're just going to add this right on in to the karat scrap now. We're going to go out and melt this up and then quart this gold. Here's our unquarted gold. And what I'll do is I'll get the tap water off of here. We'll get this in a beaker and start refining it. I've got all the tap water rinsed off of the unquarted gold now. What we'll do is we'll start pulling all the silver and the base metals back out of there now with nitric acid. This is some dilute nitric acid from a previous refining. I'm going to dump that right on in on our unquarted gold now. Now we'll cover this up. We're going to set this up on the heat and start dissolving out the silver and the base metals from the unquarted gold. Some viewers have been asking why can't we use cement silver to unquart the gold, and there's a good reason. And if we used cement silver to unquart our gold, then the platinum and the palladium would tend to build up in the silver once we pull it out of here. And when we cement it out on copper, the platinum and palladium will cement out with the silver, and it will build up in the cement silver, and that could cause problems for us in the silver cell. Here I've got my small electric furnace running to melt up some of the cement silver so we can pour it into granules. I've got it poured into granules down here, and the reason I'm doing this is because I've run out of my impure silver to feed the silver cell. So we're going to be pouring some cement silver into granules in this bucket. Here you can see all my impure silver is gone now. I've run all 26 pounds of it through my electrolytic silver cell. The cell's ready to be cleaned out, so I need to shut this thing down and harvest the pure silver crystal out of here. I won't be doing that during this video though, because try to make this a little bit shorter and just refine the gold. I was just showing this as an example of what we do with our silver that we pull out of our gold refining. Silver is a byproduct of my gold refining operation. Normally I would use my propane fired large furnace to melt the cement silver, but we've got some bad weather out there, so I can't fire that furnace up. So here I'm going to use my small electric furnace. I'm doing two things at once in this video, trying to melt this cement silver and trying to refine the gold at the same time. This is our first nitric acid boil. It's complete. I'm pouring off that solution. It's going to be full of silver, so I save it. And what we're doing here is that in quarted gold, we've lowered the carat of the gold down to 6K, or 25% pure gold and 75% silver and base metals. And with the carat of the gold that low, what we can do is use these nitric acid boils to completely remove all of the silver and all of the base metals with these nitric acid boils. The nitric acid can penetrate deep into the core of each piece of those of that encorded gold and not touch the gold, and just pull the silver. The silver has a lot of volume when it's in a powdered form like that. As it melts, it drops down into the crucible and there's more room in there. So here I'm recharging the crucible with some more cement silver, and I want to try to fill that thing up before I pour the charge of molten metal into the bucket of water. Here we have our second nitric acid boil, pretty much complete. And these nitric acid boils do such a fantastic job at cleaning the gold that when we get done with these boils, the remaining gold in there will be very close to 3/9 fine, just like it is, without any further refining. Inquartation and then parting with these hot dilute nitric boils is one of the most valuable refining techniques that I've ever learned. Here I've added a little bit more distilled water. Now we're going to add a little bit more nitric, and this will be our third nitric acid boil. It's taken almost an hour to melt a full charge of silver. Now what we're going to do is we're going to pick up the furnace and hold the crucible in there with a pair of metal tweezers. I'm just going to pour the molten metal down onto a wet board that's suspended in that metal container of water. This does a good job of causing the silver to spatter into tiny particles or tiny granules that are suitable for running through the electrolytic silver cell. And I keep the crucible in the furnace so that it stays nice and hot. If we pulled the crucible out of the furnace, then it would cool off rapidly and we just have to heat it back up. So leaving the crucible in the furnace while I do the pour is a technique I learned from the jeweler, and he's the guy that taught me to do that. And it seems to work out pretty good in keeping the crucible hot and speeding the process a little. Our third nitric acid boil is complete, and you'll notice that the solution that I'm pouring off is becoming lighter in color, and that's because we're pulling more of the metal out of that encorded gold, and there's not very much metal left in the encorded gold, and that's what these nitric acid boils do. They penetrate to the core of each piece of the encorded gold and pull out all the silver and all the base metals and leave behind nothing but pure gold. Here's a look at the impure silver shot, about 98 to 99% pure. Small little granules, perfect for running through the electrolytic silver cell. And now I'm going to move the pieces out of the way down on the bottom of that container, so when we pour the next charge in, we don't weld any of the molten silver to those pieces that are already in there. Nitric boil number 4 is complete. We're just going to keep pouring the solutions off into that silver jar. There's going to be a whole bunch of extra nitric acid in that solution. And later on, what I'll do is add pieces of silver to the solution to consume all of that excess nitric. And here's a look down into the beaker at how our encorded gold is looking so far. Here I'm adding a little bit more distilled water. I'm going to set it back up on the heat, and we're going to add some more nitric acid. And this will be our 5th nitric acid boil. I've got a second charge of molten silver ready to be poured. And so we're going to go ahead and pour this into our apparatus here to form some more silver granules. Here you get a look at how the apparatus is configured. It's a submersible pump that pumps the water up through a tube that's fixed to the top of that little wooden ramp with a screw. It just shoots a jet of water down onto the wood to keep it cool while I'm pouring on the molten silver. And here's a look at our nice fine granules of impure silver shot for the silver cell. Here you can see I've drained off all the water from our impure silver shot and put it in another container. And I've got it sitting on a hot plate, and we're going to dry it out so we can get a weight on it. In the meantime, I'm going to pour off this 5th nitric acid boil. If you notice there, we still got just a little bit of color going on in there, which means we're still pulling a little bit of copper. If we're still pulling copper, then we're probably still pulling a little bit of silver. So I'm going to rinse this off real good, and then we're going to add some more distilled water and a little bit more nitric acid and do nitric acid boil number 6. This is nitric boil number 6. While we're waiting for it to complete, I've got a little weight boat here on my scale. We're going to pour the silver shot in here and get a weight. Here it is. I've dried it off completely. This is what it looks like. It's perfect size for feeding into the silver cell. And we're just going to dump it in this weigh boat. See how much we got. Looks like 1,767 grams of impure silver shot, suitable for feeding into our electrolytic silver cell. Here, nitric boil number 6 is complete. Still got a little bit of color going on in there, but that might be some platinum group metals or possibly even some gold. A little piece of gold goes over into the silver jar. That's quite all right. We'll strain that out and filter it out and put it in the paper storage and recover that little piece later on. Here I'm just going to rinse the gold real good, try to get as much of the acid as I can rinsed off. Look at that. That is beautiful. That's what pure gold looks like. In that state right there, it is very, very close to being 3/9 fine, just like it is without any further refining. That's how effective in quarting and parting with nitric is at cleaning that gold up. So now what we're going to do is I'm going to add a little bit of distilled water and just let this boil in plain distilled water. While I'm waiting for the gold to boil in plain water, I have a sterling silver dish that Mrs. Sweet picked up. I think she said she paid $41 for it. You can see right there somebody dropped it and dented the edge, and there's a ding in it right there. So people don't want stuff like that, and she got it for $41, sterling silver. I mainly use this scrap sterling silver stuff to consume the excess nitric that's in my silver jar back there. Like I said earlier, silver is kind of a byproduct of my gold refining operation. The next step is to burn the silver, burn any junk off of there before we try to dissolve it. And the main reason here is to consume the excess nitric that's in that silver jar. But I'm kind of killing two birds with one stone here. This is the first step in refining silver, is to dissolve it in acid. And so we're doing that by consuming the excess nitric in that solution. The sterling silver will dissolve, consume any excess nitric in that silver jar. Then we'll filter out any solids, add it to some clean copper and cement the silver out, melt it up into shot, and then run it through the silver cell. We're going to pour off this water boil now into our silver jar. And this is just to clean the gold up and get some of the acid off of there. Look how clean that gold is. I mean, all of the silver, all of the base metals are gone now, so that when we go to put this gold in the aqua regia, it's just going to be nearly pure gold. And that's the benefit of quarting and parting with nitric acid. So here we're going to add some muriatic acid, aka hydrochloric acid. Hydrochloric is muriatic, and muriatic is hydrochloric. There are two names for the same product. I'm going to add about 200 milliliters to our gold. Now I'm adding a little bit of sulfuric acid to react with any lead that may be present in our gold, and this will form lead sulfate, and then we can filter out the lead sulfate and remove 100% of the lead from our gold. I'm measuring out about 20 milliliters of nitric acid. We'll add this to the beaker with the gold and the hydrochloric acid. This will form aqua regia, and we're going to start dissolving our gold with aqua regia. Here the reaction has ceased. All the nitric that I've added initially has been consumed by the reaction. And we're going to add about 1.5 milliliters more nitric. We're going to add it in very slowly because that solution is hot. So we're just going to add it drops at a time. Otherwise, we could boil it over. This is called incremental nitric acid dosing. We're adding small quantities of nitric acid to the reaction. And by doing this, we can carefully control the amount of nitric going into the reaction, adding just enough nitric to just dissolve the gold. And if we do this correctly, when we get done and all the gold has dissolved, there will be no excess nitric acid left in our solution, and therefore we will not have to denox or remove any excess nitric because there won't be any to remove. Here you can see there's a few pieces of stubborn gold that have not dissolved. So what I've decided to do here is freshen up the acid a little bit by adding about 50 milliliters of fresh hydrochloric acid. This will invigorate the reaction and allow us to continue to dissolve the gold, and this should get everything to go in solution for us. Here you can see the reaction has become reinvigorated simply by adding additional hydrochloric acid. I have not added additional nitric acid here. There may very well be enough nitric acid in there to complete this dissolve. I decided to go ahead and add a little bit of nitric acid here, less than a half milliliter, and this should be enough with the fresh hydrochloric acid and this fresh nitric acid. This should be enough to completely dissolve all of our gold for us in that beaker. Here's the last few pieces of gold that we need to put in solution. Incremental nitric dosing, adding just enough to just dissolve the gold, is far superior to premixing the aqua regia 4-to-1 or 3-to-1 like recommended in the days of old. If we premix our aqua regia in those proportions, we are guaranteed to have problems with excess nitric acid in our solution when we go to precipitate the gold. This has taken about 45 minutes, maybe an hour. Pretty much everything's gone. I do see one little piece there, but I'm not going to chase after that and risk having a whole bunch of excess nitric in there. This is a time lapse of the entire dissolve sequence. Gold will dissolve in acid, just like sugar will dissolve in water. Here you see I've added some additional nitric acid to get the rest of that gold to go into solution. And coming up here in a few seconds, you'll see I've added the additional hydrochloric, and that invigorates the reaction. And then finally, right there, there we go. That's the hydrochloric right there. And then we added a little bit more nitric to get everything to dissolve completely. Our solution looks really good, not too cloudy. Now we're going to pour it through this filter, filter out any solids from our clean gold solution. Here's our little piece of undissolved gold. I just pull that out and save it. Throw it in with our next batch of carat scrap. Here you can see the filter's nice and clean, and that is a testament to how effective in quarting with silver and then pulling everything back out with nitric acid is at cleaning up our gold. Now what we're going to do is transfer the gold solution from our filter flask into a clean 1 liter beaker and get ready for the precipitation. Now we're going to use some Stump Out by Bonide to precipitate our pure gold. Stump Out by Bonide is sodium metabisulfite. It's available at Ace Hardware. Notice how the Stump Out reacts with the chloroauric acid solution and forms a beautiful red color down there. And then suddenly I forgot to test with stannous. So I'm going to go ahead and do that. It's always a good idea to test with stannous chloride testing solution, even if we are certain that we have gold in there, just to make sure before we do the precipitation. Now I'm going to continue precipitating out the pure gold. This is about 1.5 ounces of gold, so I'm going to use about 5 spoons of the Stump Out to get everything to drop out of the solution. And I like to stir it up by swirling the beaker like this. You could use a glass rod, I suppose, but some of the gold will stick to the glass rod and it puts scratches in the beaker. Swirling it, like I did there, avoids that. And now we're going to test with stannous one more time, just to make sure that we've got all the gold precipitated, and that negative stannous test tells us that all the gold has come down. And this is a time lapse of the gold settling out of the solution. This is about half an hour or so time lapse, and you see the solution is nice and clear, colorless, sitting on top of that gold. Now that all the gold has settled out of the solution there, I'm going to pour the waste off. Notice that it's clear and colorless. This bodes well for letting us know that we've got high purity gold here. I'm going to pour off the waste solution into a temporary waste container. You'll see a little bit of the gold gets poured off with the waste. It's quite all right. I let that gold accumulate in that waste container, and then we can recover it later on. I'm rinsing the gold with multiple distilled water rinses, plus a quick rinse with hydrochloric acid before we go to the next step. Here I'm adding about 100 milliliters of hydrochloric acid. I'm going to set it up on the heat and allow the gold powder to boil in the hydrochloric acid. Notice the color of the gold here. It's a dark brown color, and then as it boils in the hydrochloric acid, it turns to a lighter shade of tan, and there's a striking difference in color here between when we put it on and when we take it off the heat. Here I'm going to pour the waste off into my temporary waste container. Notice that the solution is a little bit yellow. Possibly some gold went back into solution, especially if we had a little bit of excess nitric in there with it. And that's why we've got a little bit of a yellow color as we pour that hydrochloric acid into our waste container. Any gold that's in that solution will be precipitated out in the waste container, and we can recover it later on in a separate process. And now here you get a look at the gold, how it looks down in the bottom of the beaker. Very nice. Now we're going to refine the gold a second time. Here I'm adding some hydrochloric acid, about 250 milliliters. Then we're going to squeeze in a touch of sulfuric acid just to take care of any lead that may have made it this far into the process. Now we're going to cover this up, set it up on the hot plate, and start heating the mixture of gold and hydrochloric acid. Here I'm going to measure out about 25 milliliters of nitric acid, and we're going to pour some of it into the beaker with the gold and hydrochloric acid to form aqua regia, and redissolve the gold a second time. Notice that I'm only pouring in a portion of the nitric here. I'm going to save a little bit in reserve, and what we'll do is allow the reaction to take place, and if we need to, we'll add a little bit more nitric acid to get the rest of the gold to dissolve completely. By doing this, we can control the amount of nitric going into the reaction and avoid having to denox the solution prior to precipitation. And this is a time lapse speeded up about 4 times normal speed. It's amazing that we can dissolve gold and put it into solution like this. It's a very non-reactive metal, and if we put the right combination of acids in there, hydrochloric and nitric mixed together, we can get that gold to dissolve and go into solution completely. And now here we've got the gold to dissolve completely. I'm going to take it down off the heat and let it cool off and get ready to filter it. And I did set up my GoPro and get a time lapse of the entire dissolve sequence here. This took about, I think it was about 45 minutes, because I let the solution boil until all the fumes cleared up in there to guarantee that we've got all the nitric. Here we're going to add some ice to cool the solution off, to dilute it, and also to precipitate out any silver chloride that may have made it this far into the process. Once we get it cooled off and diluted, I'm going to filter out any solids in a filter. Shouldn't be much in here in the way of solid or contamination material, but we filter it anyway. And then here, I'm going to rinse the filter paper out to get all the color out of it. If you notice, the filter is pristine clean. Now we're going to remove this filter. I'm going to cover the gold up in the flask and get it out of the way and get ready for the precipitation. Now we're going to set up to do a SO2 gas precipitation. I'm adding the SMB to the gas generator flask, and then we're going to rinse the funnel with some water and form a slurry out of the SMB down in there. The reaction happens better when it's in a slurry form. That's the bubbler flask. The gas will come out and bubble through that sulfuric acid. Here is an addition funnel, a vented addition funnel. And we'll clamp that on top of the gas generator flask. And now we'll add the delivery tube off the discharge of the sulfuric acid bubbler flask. I'm adding the chloroauric acid solution to a large beaker. It's a nice clear solution which bodes well for high purity gold from this precipitation. Now this reaction happens better from a dilute solution, so I'm adding about 1.5 liters of distilled water to dilute the chloroauric acid solution. Here we go. We're going to start dripping some of the sulfuric acid down into the SMB slurry and we're forming SO2 gas now. The SO2 gas will precipitate the pure gold out of that chloroauric acid solution. This entire reaction took about 5 minutes. Here I've got this footage speeded up just a little bit. It'd be kind of boring just sitting there watching the SO2 gas bubble through that acid solution, chloroauric acid solution. And here in a minute you're going to start seeing it change colors. Some folks recommended putting a diffuser tube on the end of that delivery tube, and that is just not possible. In the book, in the instructions on how to do this, it calls for a minimum of a 1/4 inch diameter delivery tube. Otherwise, if you put anything in there any smaller than that, the end of the tube will become clogged up with gold powder, and then the reaction will cease because the gas can't make it through a plugged up tube. So we need a 1/4 inch tube, delivery tube, on the end of that glass there, and we have that. Here you can see the reaction is taking place. The solution becomes nearly colorless, and then it flashes over and turns brown. If I get the dilution just right, it's very striking. Here you can kind of see a little bit of purple in there. That's colloidal gold forming in that solution. And now the reaction is nearly complete. SO2 gas never fails to please. It's mine, and quite sure upon yours, favorite reaction to watch. And this is speeded up just a little bit. If you look down into the beaker, you'll see some pure gold flakes floating on top of that solution. Here's a look at the apparatus. The vented delivery funnel with sulfuric acid drips the acid down into the SMB slurry, bubbles it through that sulfuric acid flask in the back there, and then we pipe the SO2 gas down into our reaction beaker and get the pure gold precipitated out. Now we're going to test with stannous to make sure that we've got all of the gold precipitated. There you are, negative stannous. Means all the gold has come down now. Now what we'll do is get the delivery tube out of there, rinse it off, get the gold rinsed off of it. And we'll set the delivery tube out of the way. And now we'll shut off the acid flow down into the gas generator flask, cover it up, and let the gold settle completely. I've allowed the gold to settle overnight, and I got my headset back. The receiver on it froze up and would not shut off or reset, so that's why I've been narrating this entire video. But I got the headset back now. I have to let the battery run down, and then it shuts off, and then I can turn it back on and connect the headset to it. But here's our gold. I'm going to pour off this waste solution. Alright, here's a look at the gold down in the bottom of our beaker. Now I'm going to transfer this gold into a smaller beaker so that it's easier to handle. Now we're going to rinse the gold off a little bit here. Probably not all that necessary because we use the gas to precipitate. I'm just going to pour the rinse water off into our temporary waste container. And now what we'll do is add some hydrochloric acid to the gold. And I'm going to set it up here on the heat and give it a quick boil in hydrochloric acid. It's been boiling now in hydrochloric acid for about 10 minutes. What we're going to do is pour this liquid off now into our temporary waste container. Color is beautiful. Alright, I've rinsed this off multiple times with distilled water. Let me get this last one poured off. And then what we're going to do, I think, is add some more distilled water. And give this a quick boil in just distilled water. While I'm waiting for that water to boil, what we're going to do is get our silver cell harvested here. I've got a beaker down here with a piece of copper in it. And what we're going to do is add the electrolyte to this beaker. Here you can see the silver is starting to come out of solution almost immediately. I'm going to add a little bit of distilled water to this, make sure we're diluted properly. Stir it up a little bit. Now we'll scrape down the sides of the silver cell and get our pure silver crystal. Now let's get our silver crystal into this beaker so we can rinse it off and recover all this beautiful silver that we've grown in our electrolytic silver cell. Here's our silver crystal from the silver cell. I'm going to add a little bit of distilled water here and rinse some of that electrolyte off of there. And now what we'll do is pour this rinse off into our beaker that has our piece of copper in it, because this rinse will contain some silver. I've rinsed the pure silver crystal off with some distilled water, And what we've done is added the rinse water over there to our cementation beaker. And all the silver will cement out of that solution onto that piece of copper. And now what we'll do is just cover this up with some distilled water. And then once I get all the every bit of the electrolyte rinsed off of the silver crystal, we'll dry it out and put it up, store it. This is our silver nitrate solution from the silver cell. It also contains copper nitrate. That's why it's a blue color. Silver nitrate by itself is clear, colorless, like water. And what's happening here is in accordance with the reactivity series of metals, copper being more reactive than silver, is cementing the silver out of that solution. That material falling off the piece of copper there is pure silver. And the copper in that solution will stay in solution because the copper won't cement out on the copper. Here's the silver that's cementing out of our electrolyte. The battery ran out on my time-lapse camera, and so it's still in progress. So we'll show the full time lapse that we have up until this point. We've had the gold boiling in distilled water now for about 15-20 minutes. What we're going to do now is pour this off into our temporary waste container. Here is our pure gold, looking spectacular. Alrighty, here we go. We've got our Sunday go-to meeting, freshly glazed melt dish, ready to receive our gold. Let's see if we can get it down in this melt dish now. Careful, careful. Here we go. Just about every piece of it. Let's take it over here to the melt table. Man, stuff looks good. And let's get this thing prepared to melt us a nice pure gold bar out of it. Here we go. The estimated yield from this batch was going to be 44.9 grams of pure gold. And here's our pure gold bar that we just poured. Looks good, looks good. Got a little bit of stuff on that one end. Not sure where that's coming from. So the bar overall looks pretty good. Nice clean gold. High purity. Alright, we were expecting 44.9. We got 45.5. A little bit over this time, which is okay. I had some carat gold in there that wasn't marked. And it may have been higher carat than what I thought it was. So this will conclude the video. Want to wish everyone a Merry Christmas and a Happy New Year. Thank you for watching.